point is rotated about a circle of radius 1. So these all have radius 1. Its start and finish are shown. State the rotation in radian measure and in degree measure. All right, let's start with this first guy. All right, this is half a circle. That's 180 degrees, or pi radians. Part B, that's a quarter of a circle, so that's 90 degrees, or pi by 2 radians. C is negative 180 degrees, so that is negative pi radians. D is negative 270 degrees, or negative pi by 2, 2 pi by 2, 3 pi by 2 radians. This looks like it's one full round, but it's going backwards, so negative 360 degrees, or negative 2 pi radians. And this is going in the correct direction, 270 degrees, or 3 pi by 2. Here is, oh, let's see, this is broken into 1, 2, 3, 4, 5, 6, so each is 60 degrees, so 60, 120, 180, negative 240 degrees, or, so these are going to be, each 60 is going to be pi by 3, so 1, 2, 3, 4 pi by 3, so negative 4 pi by 3, and this is going to be 120 degrees, or 2 pi by 3. Number 2, sketch each rotation about a circle of radius 1. I don't know why they keep asking us to do it with a circle of radius 1. Any circle would have the same angles. They did that in the last question too. It's a bit weird. All right, so let's start with pi. So we always start on the right hand side and we work counterclockwise, and pi is halfway across. So there we go. Part B. All right, pi is halfway around, and pi by 6 is 1/6 of that. So every 30 degrees is pi by 6, and every 60 degrees is pi by 3. And so pi by 3 is 60 degrees. There you go. You can see that I just broke this into 3, like the half into 3 pieces. So if this is 180 degrees, then it's going to go 60, 120, 180. 30 degrees and 60 degrees is something to memorize. Right, so pi by 3 you just always know is 60 degrees. Pi by 6, so 1, 2, 3, 4, 5, 6, you split it into 6 groups. So pi by 6 will be 30 degrees. I'm sure that we'll get to there somewhere. Oh, no, I'm surprised it's not on there. But that is one that is very important as well. All right, so 2 pi by 3, again, we're going to take this, we're going to break it into 3 pieces like that. 2 pi by 3, 1, 2. There you go. So part D, 4 pi by 3, it's going to be basically the same thing. 1, 2, 3, and a 4th right here. 4 pi by 3, that's broken up into 6 times all the way around. 3 times to the pi, and then 3 times to 2 pi. Don't forget, I always start on the right hand side and work my way around counterclockwise. Okay, I feel like the textbook's really trying to drive in the point that thirds of pi are quite important. 5 pi by 3, so 1, 2, 3, 4, 5. Right here, that's 5 pi by 3. Let's do part F. Negative pi. Okay, so that just means we're going to go in the opposite direction. And since a whole circle will be 2 pi, halfway around is pi. Okay, part G, negative pi by 2, so half of pi. And so we are going negative, and halfway to the other side is negative pi by 2. And last we have negative pi by 4. So that's going to just be a 45-degree angle downward. So halfway to the negative pi by 2. Right? If you cut this guy into 4 pieces, it's going to be 1/4 of that. So negative pi over 4. Now just take a look here. So we said this is pi. It's actually 180 degrees if you do it in degrees, but we want to get more used to using radians, especially when you get to calculus. Degrees won't work for you anymore when you start doing derivatives. All right, so then we get, this is pi by 3, also known as 60 degrees. This is 2 pi by 3, so 120 degrees. 4 pi by 3, so that's going to be 240 degrees, 60, 120, 180, 240. 5 pi by 3, so 60, 120, 180, 240, that's 300 degrees. Negative pi is negative 180 degrees. Negative pi by 2 will be negative 90 degrees, and negative pi by 4 is negative 45 degrees. Number 3, convert each angle from degrees to radians in exact form. Okay, so there are a bunch of ways that I've seen students try to do this and teachers try to teach us. The one that's been most successful for me is just to use ratios. So try doing this. We already know that pi is exactly 180 degrees. This is radians, this is degrees. So just always set it up. Say pi over 180 degrees equals, and we know 75 degrees. So we're going to put that, the degrees with the degrees on the bottom. And we want to know this one. All right, so now we just solve, pretend this is like x, solve for this variable right here. So I can easily just cancel the 75 degrees out from there and put it up here. And so this is actually your answer. This is the number of radians that 75 degrees is. Now obviously this can be reduced. Let's see, this can be divided by 15 and this could be divided by 15. And interesting, the degrees actually cancel each other, like they're the units. So this is 5 pi by 12 is equal to 75 degrees. All right, let's try that again for 200. So again, we have the number of, so make sure that these two are actually equivalent. So we know that pi is 180 degrees. That's an easy one. You could always do 2 pi and 360 degrees. I don't know why that would be any better though. Or pi by 2 and 90 degrees, but then you got a fraction and a fraction, so that wouldn't be so great. So just use pi and 180 degrees. Now I will say we know the degree and we know that we're looking for radians. So I put the degrees on the bottom so that the thing I'm looking for is on the top. I always like to have my variable on top. If it gave me the number of radians, well then I would put 180 degrees over pi is equal to x, I don't know the number of degrees, divided by the number of radians that it gives me to do that conversion. All right, so then we can quickly just say this 200 can be multiplied on both sides and it comes over here, so 200 degrees. These degrees cancel, and this is what, 20 over 18 or 10 over 9. So our answer is 10 pi by 9. So this 200 and 180 can each be divided by 20 to get 10 and 9, and the degrees cancel. Your pi stays. 10 pi by 9 is equal to x. Let's go for 400. Now I already know it's just going to be twice as big as 200, so it's going to be 20 pi by 9, but let's do it anyway. All right, so all of these we're looking for radians again, so they're all going to have the degrees on the bottom. I assume another question coming up, they're going to give you radians and ask for degrees, and so I would set this up opposite, obviously. Bring this 400 degrees to the other side by multiplying both sides by 400 degrees. And 400 and 180 can both be divided by 20, and you get 20 pi by 9. 400 divided by 20 is 20. 180 divided by 20 is 9. So it reduces to 20 pi by 9, and that's what x is. So anytime you have 400 degrees, you know you have 20 pi by 9. And by now I really hope you could do this with any number of degrees. That 320 goes there. And it just so happens that these divide by 20 degrees and you're left with 16 pi by 9. By now you've figured out that sometimes I don't say 16 pi divided by 9, I say 16 pi by 9. I don't know why I do that. Probably one of my teachers in high school did that when it came to radians, and a lot of math teachers do that, and so I guess I just do it. Don't think that everything is going to divide by 20, by the way. That's what happened for these last three. This one divided out 15. You just have to look for the common denominator. All right, convert each angle from radians to degrees this time. Express the measure correct to 2 decimal places if necessary. I'm just going to get something behind us here because I know that some of you might have trouble with this. 5 pi by 3 is already a fraction. The way I show you guys to convert requires a fraction itself, so you're going to end up with a fraction within a fraction. So let's deal with that now. All right, so whenever you have like a number divided by a fraction, you can rewrite that as that number divided by this fraction. And I think you guys know from previous math classes that when you divide by a fraction, it's the same as multiplying by the reciprocal of that fraction. So a divided by b over c is actually a times c over b, which is multiply the top and multiply the bottom is a over 1. So multiply the top, multiply the bottom, you get a c over b. All right, so basically if you're dividing by a fraction, this 3 can actually come up to the top. And just in case, if you ever have a fraction divided by a fraction, same thing. Take that fraction, divide it by the fraction. You could write division like this, and you'll see that that's going to be the same as AB times DC. So you flip the one that's being divided, and you multiply it. And so you're going to get AD over BC. It's as simple as that. So as you can see here, the bottom of the bottom, I just threw up to the top. So this 5 pi stays on the bottom. This 3 comes up to the top. So you got 3x over 5 pi. Now this 5 pi gets canceled and put up here. Better said, you multiply both sides by 5 pi. This 3 can get divided on both sides to get down here. And let's see, this 180 can cancel with this 3, so you got 60. These two pi's cancel each other out, and so you got 60 times 5, which is 300. Now here the degrees did not cancel out. There's a degree here, but there's no degree on the bottom, so the degree stays. 300 degrees equals x. And so we're saying, what is 5 pi by 3? Let's just confirm that. We remember that pi is a half a turn. Pi by 3 is 1/3 of that. So pi by 3, 2 pi by 3, 3 pi by 3, 4 pi by 3, 5 pi by 3 is this angle all the way around to here. And in terms of degrees, this is 180 degrees. This will be 60, 120, 180, 240, 300 degrees. So sure enough, 300 degrees is 5 pi by 3. All right, let's do part B. Remember to put the degrees on top if you're looking for degrees, because that'll keep your variable on top and it'll make life easier on you. This 0.3 pi gets crossed out. 0.3 pi goes there. These pi's cancel. 0.3 times 180. Well, we could do that in our calculator if we want. I know 0.1 times 180 is 18, so 0.3 will be 54. The degrees do not cancel, which is good because we're looking for an answer in degrees. So 54 degrees is equal to 0.3 pi, and that's in radians. What about 3 radians? Right before I do this, often when students ask me to help them with stuff like this, I have them take a guess first. Pi radians is halfway around this circle. We know pi is like 3.1415926, something like that, right? 3 is just a little bit less than that. So 3 radians will just be short of 180. So we should expect our answer to be just short of 180 degrees. All right, here's our equation. I put the degrees on top because I'm looking for degrees. And remember, 180 degrees is equal to pi. That's why we can do this ratio. So we're going to see how many degrees is equal to 3. 3 obviously will go up here. 3 times 180 over pi. Our exact answer is 540 over pi degrees. Here it says express the measure correct to 2 decimal places if necessary. Well, it's not necessary. We already have an exact answer. This is pretty good. But I do find it weird to have pi when you're talking degrees. Usually pi goes along with radians. Also, if I were to ever tell a friend of mine that he needs to measure an angle that's 540 divided by pi, he'd probably be angry with me. That's not really that helpful. He would just want to know approximately what angle. And he probably doesn't want to have to get his calculator out to see what 540 divided by pi equals. That doesn't really give you a good idea. He doesn't want to have to do the math. Just let us know how many degrees it is. So perhaps what they were assuming is we were going to just put this in our calculator. And in that case, we will round to 2 decimal places, and we have 171.89 degrees. And if you remember, we knew that 3 is just a little bit less than pi, and so we knew that our answer would be just a little bit less than 180 degrees. So this makes me feel good. All right, part D. Yeah, you can see here I'm taking a bit of a shortcut. 11 pi by 4 on the bottom. Well, the 11 pi is going to end up on the bottom, but 4 will be an extra layer down, which will just flip it back up to the top. So I'm going to say 180 over pi. This time is 4 times x over 11 pi. So this 4 is really kind of down here, but we know it flips to the top. This 4 can now cancel out and go to the bottom here. This 11 pi cancels out and goes to the top here. These pi's cancel from the top and bottom. 180 can divide by 4. That'll be 45 degrees. And that's 4. So 45 times 11. Let's see, 450 and 495. The degrees don't cancel. So I will admit, like most of my students, I'm sure, don't reduce it like that. They just straight up say 11 times pi times 180 degrees divided by 4 divided by pi. And that will get you 495 degrees as well. So again, here, like I did a whole bunch of reducing. You could have just said 3 times 180 degrees divided by pi, and you would have gotten 171.89 degrees. Here, you got your 0.3 pi. You bring it up there. You say 0.3 times pi times 180 degrees divided by pi, and you'll get 54 degrees. Number 5, determine the measure of the central angle that is formed by an arc length of 5 centimeters in a circle with a radius of 2.5 centimeters. Express the measure in both radians and degrees, correct to 1 decimal place. All right, before we go any farther, let me show you something really important to understand. When people hear pi, sometimes they forget that pi is like 3.14. So the angle all the way around the circle when you're talking in radians is only 6 point something, approximately 6.28, let's say, or 2 times pi. That's why it's important that, before we used to say, hey, make sure your calculator's in degrees, not radians, because when you would say, like, let's say you do the cosine of 90 degrees, if you were in radians, the calculator actually thought you're going around the circle a bunch of times. Like pi is here, that's 3, 6, 9. Actually, it's a bit more than 3, a bit more than 6, a bit more than 9. That's only one, that's 1.5 times around, and we're only at like 9.4 radians. So you end up going like almost 15 times around the circle, and who knows where you end up, and that's your angle that it thinks you're talking about. All right, so radians is very, very different from degrees. And right now, so if I want to just say 1 radian, how far is that in degrees? Well, 3 radians is almost 180 degrees. So 1 radian will be like almost 60 degrees. It's actually 57 point, let's say 296 degrees approximately. It's a little bit bigger than that. To find out, you could easily just say, 180 degrees over pi is the same as how many degrees over 1. And when you solve for that, you're just going to get 180 divided by pi is what x is equal to. And that's like 57.2958, like I said before. So when you're thinking in radians, think 1 is about 57, 58 degrees. 2 is twice that. 3 is just short of 180 degrees. So start thinking in that way. All right. Now, when we have a circle that has exactly 1 centimeters, well, then that's pretty cool, because exactly 1 radian, which is like 57.296 degrees, so just over 57 degrees, well, this arc length will actually be exactly 1 centimeter. That's how we made radians, because we know that the arc length halfway around a circle with radius 1 is pi, right? The circumference of a circle is pi times diameter. So since the diameter is 2, then pi times 1 would get us halfway around, right? So that just means that there's this is 1, 2, 3 centimeters, 3.14 centimeters to get halfway around, and it's also 3.14 radians to get halfway around. So they kind of match the angle to the number of centimeters it takes to get around in order if we have a 1 centimeter radius, right? Well, if we have a 2.5 centimeter radius, well, then it's going to take 2.5 as much times to get around, right? So this length right to here won't be pi anymore. It'll be 2.5 times pi, right? So this length is 2.5 times pi, but the angle is still pi because the angle isn't based on the length of this arc. No matter what size the circle is, the angle is based on the length of the arc if it's a circle with 1 centimeter or 1 whatever measurement around. So now they're trying to trick us. They're going to miss a radius of 2.5, and so when their arc length is 5, that's going to be about 2 radians. 1, 2 radians, right? 2.5 will give you 1 radian, 2.5 will give you another radian. So it's going to be about 57.3 degrees times 2. It's like 114.6. But let's figure it out exactly. So we're going to say it has an arc length of 5 centimeters, like that. Okay, and now let's just kind of see what that would be if you only had a radius of 1. So we're going to divide this by 2.5 and divide this by 2.5. And that will give you an arc length of, well, 5 degrees divided by 2.5, or 5 centimeters divided by 2.5 is 2 centimeters. Okay, and so since now we have it on a circle with a radius of 1, then the arc length is actually equal to the angle, which is 2 radians. So part A, the answer is 2 in radians, or let's find what that is in degrees. So we're going to say 180 degrees divided by pi is equal to, I don't know how many degrees, divided by the number of radians. This 2 can come up here, and so x is just equal to 360 degrees divided by pi. Let's put that into our calculator. And like we said before, x is approximately 114.59 degrees. All right, part B, determine the arc length of the circle in part A if the central angle is 200 degrees. So we're going to move the central angle to 200 degrees. So this is 180, so it's going to go a little past 180, an extra 20 degrees here. So let's draw it a little farther. Let's do it in green. It's going to go right to about here. And that's going to be 200 degrees. All right, let's convert that. Now we want radians, so we're going to put degrees on the bottom this time. Pi over 180 degrees is what over 200 degrees? This 200 can cross out and come up here. 200 times pi divided by 180. I get 3.49. These degrees cancel out, right? And so 3.49 equals x. That is the number of radians. Now the number of radians will also equal the arc length if our radius is 1. But since our radius is 2.5, it's bigger, we need to multiply this by 2.5. So we're going to say arc length equals 3.49 times 2.5. Now I'm not going to be silly and clear my calculator and use 3.49. I've got that whole number, 3.4906585 in my calculator. So I'm just going to take that number and multiply by 2.5 to get a better answer. And so A is equal to approximately 8.73. And therefore, the arc length of that circle is about 8.73 centimeters. Determine the arc length of a circle with a radius of 8 centimeters if the central angle is 3.5. Well, the cool thing about this 3.5, this is in radians because it doesn't say degrees. So the cool thing about 3.5 is if this were 1 centimeter, well then the central angle of 3.5 would just mean that it's 3.5 centimeters around. The angle is also equal to the arc length, but that's only if this is 1 centimeter. Since it's 8 centimeters, then we know the arc length is going to be 8 times as long. So it's just simply 3.5 times 8. So 3.5 times 8 is 28. Now to draw this, I know that pi is about 3.14. So we need to go a little bit farther than 3.14, right to about there, let's say. And we're going to say that that length is from here all the way around to here is 28 centimeters. And that feels about right. Like if this is 8 centimeters here, then 8 centimeters is going to go to about 57 degrees. Another 8 centimeters to like 114, 115. Another 8 centimeters is going to go to pi, or just short of pi. So like, I don't know, 171 degrees, something like that. And then another 4 centimeters is going to get you another 20 something. So that makes a lot of sense. All right, so we saw how easy it was when you're dealing with an angle in radians. You just multiply the radians, the number of radians, by the radius, and that'll tell you the arc length. So let's just convert part B into radians, and then we'll be able to do the same thing. Once we have the radians, we just multiply by 8. So we'll start with our equation. I want radians, so I'm going to, this pi and 180, I'm going to set it up so that the radians are on top. So pi over 180 degrees is equal to x over 300. 300 gets crossed off and goes here. I already know that degrees are going to cancel. So calculator says 300 times pi divided by 180 is about 5.24. So that's the number of radians. Multiply that by 8. Of course, we multiply by 8 because the number of radians that it is the arc length only on a circle with the radius of 1. This is a radius of 8, so you have to multiply by 8. And I'm not going to be silly and just put 5.24 times 8. That would be a lot too much. Like that would be way too much rounding. So I'm going to take the number that's already in my calculator that's not rounded and multiply that by 8, and I will get approximately 41.89. So if we have 300 degrees, which is like 160, 120, 180, 240, 300 degrees all the way around here, that arc length is going to be about 41.89 centimeters. All right, convert to radian measures. We've done enough of these already. I'll do one for you and let you do all the rest. But the conversion is just pi and 180. These are equivalent, so you just say pi divided by 180 degrees equals x over 90 degrees. I put the pi on top because we're looking for radians, and that will get my variable on top. If we were looking for degrees, I would have said 180 degrees over pi equals x over, and then whatever the radian measurement is. Anyway, so we do the exact same thing. Because I put the x on top, I can just cancel the bottom one out. 90 degrees here. In my calculator, I write 90 times pi divided by 180, and I will just get pi over 2, or we can say that's approximately 1.57 radians. Pi divided by 2 is about 1.57, but pi by 2 is exact, and that's one of those things that, you know, within the week, everybody's going to just know that pi by 2 is equal to 90 degrees. 270 is going to be 3 pi by 2. This is going to be negative pi. This is going to be pi by 4. This is going to be negative 3 pi by 4. This is going to be pi by 3. So we should know all of these by heart. Anything that's a multiple of 30 or 45 is we're going to know by heart. All right, same thing. We've done enough of these, but I will do one of them. Let's do part H for you guys. So you see I chose to put the pi on the bottom and the 180 on the top. this time because this time we're actually looking for degrees, so I want the x to be on top. And negative 9 pi over 2, well, I'm not going to put a fraction in a fraction. That 2 that's down here is going to swoop up to the top, so it's going to be 2 times x over negative 9 pi. Now when I move things to the other side, this 2 comes down to the bottom. Negative 9 pi goes to the top. And probably the simplest thing is just to go negative 9 times pi times 180 divided by 2 divided by pi and see what you get for x. Personally, I don't mind reducing this, so this 2 is gone. This becomes a 90 degrees. That pi crosses out with that pi. 90 times negative 9 is negative 810 degrees, and that is the number of degrees. Let's see if that kind of makes sense. Negative 9 pi by 2. So this is negative pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, which is 2 pi, 5 pi by 2, 6 pi by 2, 7 pi by 2, 8 pi by 2, so it's twice around, and we're already at 4 pi, 9 pi by 2. So we went 2 times around plus a quarter. And negative 810 degrees, well, that's going to be, do the same thing, go 2 times plus a quarter. So this is going to be once around, that's 360 degrees, twice around, that's 720 degrees, and another 90 degrees. Sure enough, 720 plus another 90 is negative 800, well, the negative of that because we're going in the negative direction. That is 810 degrees. Negative 810 degrees makes sense.